And recall, last lecture we talked about the atom and evidence of the atom and experiments that led to our understanding. And so we're going to pick up there. And remember, our model of the atom is shown here. We have a nucleus in the middle, which is very small, followed by the electrons somewhere on the outside that take up most of the space. Within this nucleus, which contains all of the mass of the atom, we have two particles, the proton and the neutron. A proton is a positively charged particle, and a neutron is a neutral particle. And the electrons are negatively charged, and they are somewhere around the nucleus. So again, all of the mass is in the nucleus, made up by protons and neutrons. All of the volume or size is made up by the electrons. We can summarize the proton, electron, and neutron. A lot of times you'll see a proton abbreviated with a lowercase p, an electron, a lowercase e, a neutron, a lowercase n. We can identify the mass of these, and while you can look up the actual number, the more important mass is probably here in terms of what we call atomic mass units, or AMU. And we say the mass of the electron is essentially negligible, or 0, and the mass of the proton and neutron is 1 atomic mass unit. So for every 1 proton and neutron, you get a mass of 1. For every electron, that adds essentially nothing to the mass. For a charge, we can quantify the charge of the electron and the proton, but again, probably the more important value is just think of the proton as a positive 1 charge and the electron as a negative 1 charge. All right, so when we think about charges and mass, these are the two columns that we're going to concern ourselves with. So now we'll go through each particle in a little bit more detail. So the proton first. So the proton is a positively charged particle contained in the nucleus of an atom. It contributes to the mass and charge of an atom. All right, so proton, or lowercase p, has the mass of 1 atomic mass unit and is a charge of positive 1. The key thing about the proton is that each element is defined by the number of protons present. So the number of protons in the nucleus is what defines what type of element we have. And we symbolize that through what's known as the atomic number. Right, so the atomic number is nothing more than just the number of protons in the nucleus. And when we think about an elemental symbol, the atomic number you'll sometimes see written as a subscript to the left of an elemental symbol. Right, so atomic number gets the abbreviation Z. So an example of this would be hydrogen. So if we have hydrogen, our simplest atom, right, we can see the elemental symbol of hydrogen is capital H. Remember, the first letter of any elemental symbol is always a capital letter. So it's a capital H, and there would be a 1 for the atomic number, meaning every hydrogen in the universe has 1 proton by definition. Another example would be this element here, oxygen, O for oxygen, which has 8 protons in the universe, so in the nucleus. So every oxygen atom in the universe has exactly 8 protons in the nucleus. On our periodic table, you can look up a whole bunch of different varieties of periodic tables, but again, the element is defined by the atomic number. So somewhere in the elemental symbol, you will see the atomic number, 1 for hydrogen, 3 for lithium, 11 for sodium, 5 for boron. So that atomic number tells you the number of protons in the nucleus of each element. Our second subatomic particle is the neutron. So the neutron is neutral. So it does not contribute to the charge, but it does contribute to the mass. So it's located in the nucleus and has a mass of 1 atomic mass unit, so the same mass as a proton, but no charge. And so we often refer to what's known as the mass number of an atom, and a mass number is just the total sum of protons and neutrons, the two subatomic particles that contribute to mass. So we'll see the mass number in 2 different ways. If it's in an elemental symbol, it'll be a superscript to the left of the elemental symbol. Or if you're writing the name of an element, we see this as a number written after the name. And you've probably heard this before when people refer to it as isotopes, which we'll talk to later. An example of that would be carbon-12. And so we can see in the elemental symbol, the mass number, and the atomic number to the left of the elemental symbol, mass number up top, atomic number on the bottom. So in our first example, we have a hydrogen atom, and it has 1 proton because it's hydrogen, a mass number of 1, and so we can see there's 1 proton from the atomic number, 0 neutrons, because this number is the sum of protons and any neutrons. For this, and then the name of this, we would call it hydrogen-1. That -1 tells us our mass number. In our second example, we have oxygen with 8 protons. The mass number is 16, so that must mean there's 8 neutrons. 8 plus 8 equals 16. And the name of this would be oxygen-16. Our third subatomic particle is the electron. This is a negatively charged particle located outside the nucleus. The mass of the electron is insignificant to the mass of the atom, so we don't really think about the electron's contribution to mass. It has a charge, however, of -1. And so when we think of the charge of an atom, the charge really comes from the difference between the number of protons and electrons. If there's the same number of protons and electrons, it's a neutral atom. If there's a different number of protons and electrons, then our atom is going to have a charge. And we're going to express that as a superscript to the right of the elemental symbol. So again, if there's no charge, then if there's no charge shown, then it's neutral or 0 charge. If it's negatively charged, we call this an anion. And it's positively charged, we call it a cation. Right, so that charge we see here as a superscript to the right of our elemental symbol. So here's our overall elemental symbol, and our examples would be, for example, here are 2 ions, a cation and an anion. And in the first example, we again have 1 proton, 0 neutrons, has a +1 charge, right? So in this case, it must have 0 electrons, right? Because it's getting a +1 charge from our proton, and there must be no electrons to balance it out. In our second example, we have 8 protons, right, and 8 neutrons, but we have an overall charge of 2-. So how do we get a 2- charge? Well, we must have more electrons than protons. We have a +8, here we have a -2, so we must actually have 10 electrons here. We must have 2 more electrons than protons to give us our -2 charge. So we can then define what we know as isotopes. Isotopes are important, and isotopes are atoms with the same atomic number, so same number of protons, but different mass number, so different number of neutrons. And so we can see 3 examples of isotopes here. We have all carbon, atomic number 6, across the board, but our mass numbers are different. So here we have 6 protons, 6 neutrons, 6 protons, 7 neutrons, 6 protons, 8 neutrons, carbon 12, carbon 13, carbon 14. And again, the key of the isotope is same protons, but different number of neutrons. All right. So this will be the end of our slide. So you can pause this video, and at this point you should be able to, of all these ions, identify the number of protons, neutrons, and electrons in each of the following. And in some cases, identify the elemental symbol and make the symbol here. The next video will be a solution to this problem, so give it a try first, then watch the next video. Thank you.